back again for the WRL talk. Just to introduce myself again, I am Sridhar Madhugiri. I am a developer on the Visual C++ team. And why am I presenting WRL? So, I don't know, a couple of years ago or so, Windows started thinking about WinRT, and we're involved with that and said, oh, we need some library to start writing these components, and WRL was the thing that we came up with. So I've been involved with it from day one. Lukash will come and help us with some of the demos. He's also worked on WRL, so we both know about it pretty well. At the same time, both of us also work on C++ CX, so we work on both the WinRT offerings from C++, so we are familiar with both of them. So what I want to do in this talk is to give you an overview of what WRL is, why would you want to use it, when would you use it, a quick overview of some of the important classes in WRL, how do you consume WinRT using WRL, and then what about project template? I want to create a WinRT component based on WRL. What do I do? And then we will go into demos where we will walk through a set of different types of creating a WRL component, adding methods, adding events, and non-default constructors and things like that. Most of our time will be spent in the demos, so I hope you'll get more out of that than me talking here. So WRL overview. So what is WRL? It's a template-based implementation for consuming and authoring WinRT components. So it's exception-free, so it does not throw any exceptions, but it's exception-safe in the sense that if you use some code, we internally use all smart pointers and everything so that we can clean up. It works at the ABI level. A lot of the talks today you looked at were about C++ CX. We're using hat, refnew, and things like that, and you did not see a H result anywhere in there. You saw return values from the function. You saw all high-level abstractions that we added in C++ CX. This is at the ABI level. That means you see H results. You cannot let exceptions cross the boundaries, things like that. And this library was specifically developed for WinRT. So why do you want to use WRL? There are some good reasons to use it. Let's go through them. First thing is, let's say you already have COM components that now you want to make them as WinRT components. WRL may be an easy choice for you, but especially if you're using ATL for your COM components. You have a requirement that in your code, you cannot use exceptions. There are some teams that have that requirement, and if that is a requirement for you, you can use WRL. You want to interop with COM. As you saw in some of the demos earlier, like DirectX. I don't know how many of you noticed that WRL was used in some of the previous demos. So DirectX samples and template, the project template for DirectX uses WRL. Both of the DirectX demos had WRL in them. The other scenario is there are certain interfaces that you don't have as WinRT interfaces, and WRL is a way where you can mix both WinRT interfaces and COM interfaces together. Again, you have a no C++ extension requirement in your code. You can use C++ CX, but there are certain teams that say, hey, we don't want to use any non-standard C++. It is platform-specific code. Even WRL is platform-specific in the sense it's only going to work under WinRT, but it doesn't use any C++ extensions. So those are some of the uses. And the last one is the fine-grained control. You get to see almost everything that happens in your component. There's nothing hidden from you, no abstractions. So that's the last reason. So let's look at the WRL classes. I'm not going to go over these concepts, but in general, there are these concepts in WinRT, and we have corresponding classes in WRL. So to create a WinRT objects, we have a couple of classes and a couple of macros that lets you easily create a fully working activatable WinRT object. Then there's delegates, which is essentially a callback across the boundary across languages, and we have facilities for you to create delegates, pass them across to other languages or across the WinRT boundary. Events, again, events is really based on delegates. So event source is a way where you can say, I am writing a WinRT component, I want to now have an event where I want to fire some event and I want subscribers. Event source lets you take care of that for you. Callback, again, is on the client side where you are saying, I am interested in receiving an event. So you can use callback to create. I mean, the delegates really behind the scenes is a full-fledged WinRT object that you create a WinRT object, pass a pointer to it to the other side holds onto it, the server side holds onto it, and calls back on that object when that event happens. So callback sort of encapsulates all of those things and makes it easy for you. And then there's miscellaneous things. So there's comp pointer and weak pointer, which are the reference counting helpers. If you've used ATL, ccomp pointer is very similar to comptr. And then there's the async base. If you're writing async operations with WRL, async base helps you in some way. Nowhere close to what you saw with, I mean, you can still use tasks and other things, but async base is used to set up certain states and things like that. There are many more classes. I don't want to go into all of them. This is more about saying, here's the key classes for you. As you start using it, you will find those and then use them. So consuming WinRT. Already you have seen a lot of examples. I'll just go through quickly, and we'll go into the authoring side of things. Okay, so there is comp pointer, which is a reference counting smart point. It helps you with reference counting. It's a smart pointer holding on to that interface. And essentially, the next thing is, I'm only trying to go with the things that I've highlighted with bold. Essentially, what we are saying here is that we have activation factory, which is also a comp pointer, and now we want a QI for IURI runtime class factory interface. As is a method on comp pointer, which behind the scenes does the QI for you, gets the correct GUID and everything. You don't need to do QI or anything else. It returns the H result. No exceptions here. That's the first one. The second thing, if you notice, is as is taking an address of the comp pointer. Normally, you might have heard everywhere, oh, don't take the address of this thing. And ATL ccomp pointer has an issue where when you take the address off, there is a possibility of a leak. We have made sure that it is safe. Address of returns a different type, not T star, T star star. So you won't get into some of the bad scenarios of using address of. And the other thing it does is when you say address of, we actually release any pointer you're holding on to so that there's no leak. So those are some of the comp pointer functionality. And of course, the last one is you have a URI activation factory. You would call methods on iRuntime class factory just using the overloaded arrow operator gets invoked. It's as if it is IURI class factory. Then there is this hash string, make reference. All of you've heard about string hat throughout today. String hat is an abstraction that hides a lot of things. At the ABI level, string is a handle. It's reference counted, there are certain requirements for it, but it's a handle. And hash string is the wrapper, is the smart pointer wrapper for hash string in WRL. what is this make reference? I think in my previous talk I talked about there are ways to take a string that you have and sort of say, hey, I'm really a Winati string. And make reference basically takes that string that you pass in and literally passes that buffer to the other side without copying. And so there are APIs in Windows to let you do that. So we use those, and so we are using make reference. There's no copy. It just sets up a dummy structure that says, oh, this is actually a hash string. Go pass it across. So it works for input parameters without problem. And then, of course, the .get there is to basically get the hash string type out of that smart pointer. It's similar. Com pointer also has a .get, so there is no conversion to a T star. So com pointer, if you just try to pass URI activation factory to some place where it takes a IURI class factory pointer, you can't do that. You have to say a com pointer.get to get the raw type. Then there's also the other wrapper for hash string, which is a full, in this case, we are get domain returns a hash string, which means it's ref counted, it comes back ref counted, and you own releasing it. And then, so what we are saying is, get the address of this internal one, just pass that address. When it comes back with the correct ref count, and when the hash string wrapper goes out of scope, it's cleaned up. So there are just smart pointers. So this is about the basic reference counting and hash string. Let's go to delegates, right? I mean, delegates is interesting because, as I said, delegate is a full Winati object. But how do we make it easier for you? So we have this class called callback. In this example, we just have to, the main part is in this callback. Callback essentially lets you specify a delegate that needs to be called when the delegate gets invoked. And we essentially wrap everything for you. It's pretty simple. You can either put a delegate there, a lambda, or you can put a function pointer or member function with a instance with 2 parameters. So all the combinations that you can think of are allowed. So this is sort of the, again, if you see there at the bottom, callback returns a com pointer of some type, and then the .get gives you the raw pointer out of there, so you can pass it as an input parameter to that API create timeout. So this is sort of the client side of WRL. So now we'll go to the WRL project template, and Lukasz is going to help me with some of these demos. Let's go quickly over the project template. Okay, so there is no WRL project template in the product. However, we have one online. So if you just go to the new project dialog and select online template C++, you will find that you can easily download and use that to start off your Winati, authoring your Winati components. Does not work with beta, so you have to wait till we release the next developer preview, and then you should be able to use that. So what does the template do? Basically a project file with the correct settings, idle file, source files, and boilerplate code to wire up some of the exports. And this is where everything that you have seen till now, where it's like, oh, you just say author a ref class, foo, everything happens behind the scenes. WRL, there's nothing happening behind the scenes, so you'll see idle files, you will see a lot of exports, you will see a lot of those things. And we'll go through the demos, or we'll walk through some of these projects, and then you can see all of those. So let's go to just looking at the default WRL project. Okay, so what we have done is we are not going to type any code. We already created projects with what we want to show you, and we'll highlight the important parts, because I don't think you want to see us typing, making all these syntax errors and everything. So we'll just walk you through what is there, but there is no magic here. So the first thing I think we want to see, Lukasz, is the project settings.
Okay,
So if you look at the project settings, the C++ project settings for the preprocessor, the first thing you see is that we have set up that macro that says only enable Metro SDK APIs. We talked about it in the previous talk, but this is the thing that prevents any APIs that are not available under Metro to be used in your app. So that's the first setting that we have set up. The next thing is the middle tool. And then in the output, middle now has been updated to generate a WinMD. If you have no middle, it was generating, earlier it would generate a header and a proxy stub and a TLB. With the WinRT switch, it now creates a header, proxy stub, and a WinMD. WinMD is the new way of exposing your APIs across languages. It contains type information that other languages can consume, including C++, CX, .NET, and JavaScript. And the last thing we want to look at is the custom build step. And this is very important. And there is a tool called mdmerge. What essentially happens is when idle runs, in a lot of scenarios, it does not have enough information to generate a valid WinMD. And mdmerge is the tool that you pass additional inputs to it. It can go fix up your WinMD and make it a valid WinMD. And so this project, the default project, sets up all these for you so that when you start off, you only get to choose the WinRT API, the Metro SDK APIs, and you get a WinMD, and then mdmerge is run, so everything is correct. So the next thing we want to look at is idle file. How many of you have used idle files earlier? Quite a few of you. It looks very similar, but there are some key differences. I think the first thing you'll notice is that there's a namespace. If you try to write a namespace in idle file for COM, you would get an error. So every WinRT type has to be in a namespace. In this, when you're trying to create a WinMD file using idle, if you put any types outside of a namespace, you'll get error. It will not compile. The next thing that you will see is runtime class. Runtime class is a new keyword that's there, and that specifies what is your WinRT object. Interface looks very similar. However, one of the interesting things there is there's an exclusive to attribute right at the end there. And exclusive to basically says this interface can only be implemented by the type that's specified. And so you're not just saying, hey, here's an interface, anybody can go implement. You can definitely do that. But if you're creating an interface for a specific WinRT object, you basically say exclusive to that class, so nobody else can try to implement that. At the idle level, I don't remember if we validated, but definitely all the high-level projections, C++, CX, .NET, JavaScript, will fail if that does not match correctly. And then the runtime class is where the other attribute we have is the activatable class. What it's saying is, hey, this particular WinRT class is activatable, and there's the version information that tells you which version and things like that. And of course, you specify the interfaces that that class implements. So that's sort of the default idle file we generate. Now if we go to modules, so I'm going to skip over this one. It basically is a boilerplate code that sets up, there's a certain set of exports you need. It wires up all the exports with the WRL infrastructure. I would expect that 99% of the time nobody will touch this file. Now we go to the header. This is where it gets back to WRL finally. Because there's so many other things you need to set up that by the time you get to C++, you have to set up everything else correctly. So one of the things, if you notice here, is in idle, we just had a namespace that said WRL class library 1. But here, what happened? Why do we have ABI? This is a problem that's for C++ and C++ CX. What happens is in the WinMD, you have a name that's the namespace dot type. And if idle generates the same namespace, and we try to mix both C++, CX, and WRL or the ABI level in the same project, now there's going to be a clash of types because they're obviously different signatures. They're not the same. And so since these interfaces are ABI level interfaces, we prefix all of those with the ABI namespace. So now let's get to the runtime class. So runtime class is the first WRL type you're seeing there. It's essentially saying I want a WinRT class, WinRT object that implements that interface. And by doing that, it implements 4 of the 6 methods you need on a WinRT class. Any WinRT object requires you to implement IInspectable. So runtime class implements addref release, query interface, and get IIDs. And it's using those template parameters to do that work. Inspectable class lets you specify the name of the runtime class that other people see. So if you want to now publish this component, other people want to activate it, that is the name they will use in their code. And then there's a trust level, which is the base trust. And the last thing we want to look at is the activatable class. Activatable class essentially says, now please wire this up with a factory that can be used across the ABI through the standard exports. So we talked about module, and activatable class hooks up a factory along with its along with the exports, the WRL infrastructure for the exports. So that is really all it is that takes you to write in WRL. However, you need to make sure that you match idle and WRL so that they're in sync.
So that's where you can see how those are actually.
So I think what we did was in all of these samples, we just created a simple JavaScript application, and then we invoke this component from there. And so basically, all we do here is we call it and we get the name of the class, which is WRL class library 1.winrt class. That was the name you specified with inspectable class macro. So that's the first demo. I'm not going to switch back to slides. All I have in the slides after each of the demo slide is exactly what I talked about, so that when you go back and go through the slides again, you know exactly what we talked about here. So let's go to the second one, which is we want to now, okay, we had an empty WinRT class without any methods, anything on it. Let's add a method. Let's do some work. So first thing you want to do is go add that method to the interface in idle. You're now specifying in idle what the interface definition is. We added a method. Now we have to go back to WRL, add a similar method there. The one important thing to remember here is the standard call, because this is similar to COM. All methods have standard calling convention. So here we implement the method. If you look at it, it looks very similar to what's in idle, but you're specifying the same information in 2 places. And all we do here is add and return that one. Nothing else changed between this project and the next one. The other thing I think we'll also do is we'll work with Jaime and Charles and make sure that these projects are online, so you can also go diff the projects to see what changes we made. But those are the only 2 changes. You want to run that again?
Mm-hmm. So this one actually just adds some 2 values. Nothing special, however, it shows just WRL.
So we just invoke the method we had earlier.
The code that calls WRL is hid in the JavaScript, so everything is wired up there, so you can just
and we wanted to make sure
objects.
that we didn't actually bore you with typing everything. The JavaScript code is just invoking this, activating this object and invoking it. We can go through quickly one of those.
So as you can see, actually we define the controls, and the simple consumption is in default JavaScript. It's just the function, just gets the elements and just calls the WRL objects and invoke the calculate method on the object.
So one of the other things I think that also we have set up the project reference, just like you saw in other demos. The project reference has been set up so the JavaScript project references the WRL project, gets the WinMD automatically and everything else. So let's go to the next one, which is to add an event. till now, hey, you know what? It's not too difficult. Why are you saying this is difficult to do or not tedious? Right now, we added a method. It wasn't a big deal. Now, let's try go add an event and see what happens. So first thing you need for an event is a delegate. That basically is the signature of that function that gets called. Okay, so we have to go define a delegate in idle. So if you look at it, delegate is a new keyword, and it's just the signature of the delegate. Again, the attributes are there and everything else. Here's where it gets interesting. Now you want to say this iWinati class interface has an event named calculate event. Oh, why are there two calculate events? There's an attribute saying event add, which requires us the exact correct signature, which is to say the first parameter is the in parameter, which is the with the type of the delegate for the event or the event signature. The second one is the event registration token, which is an out-ret val. And then there's the event remove, which also has to match the name, which is calculate event, and then it needs to take an event registration token as an input. So the first thing is, right now, you have to now duplicate that information, make sure you get the signature right. Let's go to the WRL side. So first thing is you're implementing an event. So many subscribers could say, I want to receive this event. So we have a class called event source. The other interesting thing, if you saw here, is in the idle file, we said calculate event. And here we have to use the interface name. It's no longer the name of the delegate that you gave. It's the interface that idle generated. So you also need to think about, understand what idle does with your file, and look at the generated header, because there's a lot of things happening behind the scenes. So we have event source, which is templated on that interface, and it's just a member variable. And then we need to go implement those two, add and remove. Here's the next one. So add underscore is a prefix you need to add to that add to the event add function. That is the sort of prefix you need to add. Similarly, you have to add remove underscore as the prefix for the event remove function method. Once you do that, though, we made it easy for you. You can say events.add. Events is basically the event source variable. Same signature as the add and remove methods, add and remove, and it takes care of it for you. So we have wired up an event on the JavaScript side. So, and then I think, the last thing is the invoke all. So now people have subscribed and something happens and you want to let them know that the event happened. Invoke all, just call that. We go walk through each of the delegates in that list that we maintain that have been added, and then we call back on that. So pretty trivial when you use it here. The key part is understanding what happens in idle and what happens in source and keeping them in sync.
So the same actually example, however, we wire up the event as well. So you're going to have the notification that says
so calculation done is basically we receive the event and notification.
You can see actually here that this is the event that actually notifies JavaScript about it.
So that's adding events. Let's go to the last one, which is, I don't know if in any example we saw a case where you could activate an object that took parameters. You say ref new. I think URI is a case where it takes parameters when you construct it. So let's go try to do that with WRL. So what does it involve? The first thing it involves is you need to create a constructor interface for your Winati object. So the constructor interface basically is, again, a interface that derives from iInspectable. You need to make sure you put the exclusive to attribute saying this is exclusive to this particular class, and you write the different constructor methods you want. In this case, we said we want to add wanted to take a Boolean, and of course the last parameter, the out.retval parameter, is very important. It is required to match the type you specify with Winati with exclusive to attribute. And so we added a new constructor method so you can activate that object and pass a value when you try to initialize it. And then the last thing we do is in the runtime class, we specify the factory interface in the activatable. Lukash, you want to go back to the idle for a second?
Back to the idle, okay.
So if you look at that one, in the activatable attribute, the factory class is specified. So that tells WinRT and people who consumes WinMD saying this is a constructor interface and it's okay to activate it with parameters. And then going back to the code, so we need to create now a custom factory. Till now, we were using a default factory that knows how to default construct your object. But since it's no longer default construct, we need to create a custom factory. So derive from activatable factory, specify your constructor interface, go implement that method. And we have helper functions for you to instantiate the class, make and initialize, template on the type you want to create, and then pass in the parameters that you want to pass. The only thing here is that the first parameter of make and initialize should always be the type that you need to create. And then the rest of the parameters can follow. So that's creating a factory, custom factory. The next thing is WRL, there's no exceptions, which means your constructors cannot throw exceptions. And if you're normally passing some value to the constructor, chances are it can fail. So how do you get around it? Two-phase construction. And essentially, you write this function, runtime class initialize, specify the parameters you want for constructing your object, and make an initialize. Essentially, this creates an instance of that object, and immediately calls runtime class initialize. And if that fails, it frees up the object, so there's no memory leak, returns error that you return from runtime class initialize. So it's two-step construction behind the scenes, but it's all hidden in make and initialize function. And the last step that you want to do is, now you want to tell the rest of the WRL infrastructure that you have a custom factory for this. And now we changed the activatable class macro to be activatable class with factory, and you specify both the object that you want to instantiate and the associated factory. So looks pretty trivial. It's tedious more than difficult to do. There is no magic here. And so if you think about it, if you do something similar in C++ CX, all you would say is ref class, have a public constructor with a type, have a method, put an event, and you're done. And all this actually is taken care of you by C++ CX, by the compiler. But in WRL, there's nothing to help you here. You have to go and write this code yourself. So let's go back to trying to run it.
So actually the difference here is that in the factory, we pass the parameter that says subtract or add. And that's why we can this way differentiate the calculate operation. So we have add, we have subtract. I can show you guys also the code in JavaScript that actually does that. So the only difference here is when we calling our WRL class, we just passing the parameter. But all this work in WRL was required to be able to construct the object. So as you can see, IDL file, it's kind of big one. If you think about events, how much stuff you have to put there to make it work, plus the class itself contains quite a bit of logic to do the very simple stuff.
So, I mean, we have developed WRL. We like it. We totally love it. But if I was to write something where you do not want to have exceptions, WRL is your story. But if you're OK with exceptions and don't need a very fine-grained control, you should see if C++ CX works for you. But at the same time, let me talk about a couple of other things with WRL. One of the things is, let's go back to the method that you have. Scroll up. OK, so there's your method implementation, right? for the calculate. You have to scroll up a little bit because it's not on the screen here.
Okay.
So one of the things here is, let's say in here you use some C++ library, and that library throws exceptions. You cannot let that exception go out of this function, because at the ABI level, it is required that you do not let exceptions pass that boundary. If there's an error, you need to return H result. If there's no error, you return SOK. If there's error, return an error H result. But you cannot let a C++ exception pass across the boundary. So it is very important that you make sure that you don't let exceptions cross this boundary here. And all that is taken care of elsewhere in all the other projections. .NET, C++, CX, JavaScript take care of that translation for you. But again, WRL, close to the metal. You don't get anything for free. You have to do all the hard work. So I think we should go back to the slides. Okay. So I'll quickly go over this one. So I have all the things we talked about what we did in each of the project is on the slides. I know there's a lot of information we gave you, and it's all captured here. So it's fairly easy to use, but sometimes tedious, because you have to repeat information multiple places. Exceptions cannot pass the ABI boundary. That's very important, because if you throw an exception and it crosses the boundary, it's undefined behavior. The best thing that can happen for you is the app is terminated. If that doesn't happen, then you don't know what state your app is in. So be very careful about exceptions in these implementation of these methods. It's, again, as I said, tedious because you repeat information in two places. This is not new. I think if you've done COM programming, you know about this. It's always there, and you have all hit issues where, oh, I changed some information in the idle file, forgot to change it in the CPP. The same issues apply to WRL. There's nothing new. There's nothing that we can do to help you in this place, because they're two different compilers. They don't talk to each other very well other than through headers. And that's about it. Any questions? We have time for questions, yeah. Charles? Okay.
Ask. You say that you can't throw exceptions across the boundary. So you also mentioned, I think, that if you use all the ref class niceties, that the underlying stuff is actually WRL, right? Is that correct?
No, some parts of it is. Not everything is WRL. I mean, with WRL, you see everything that needs to happen. But we don't use WRL. There are some couple of places where we use WRL. So let me separate out. If C++ CX, the compiler generates a lot of this code that WRL you have to do manually with WRL. But there are a couple of places where there was no need to use a compiler to do that work because it was already in WRL. We just used that code. But if you think about it from a high-level point of view, if we can just go to some. Yeah. So if you look at this calculate method, when you write it in C, sorry, can we go back to the demo machine so that it's easy to explain when you're looking at code. Essentially, the calculate method, if you saw, returned H result and took 3 parameters in WRL. If you write it to C++ CX, you would say it's a function that takes 2 parameters and returns an int. And so that mapping has to be done by the compiler, because it is about saying, hey, you know what? At the ABI level, it's really H result with 3 parameters, 2 input and 1 output. But when you write it, you are writing it as if it's returning a value, which is more natural for you, as opposed to a out parameter.
Okay, well, with C++ CX, do you know what the underlying mechanism is that they use to transfer exceptions over between the boundaries?
You simply catch the exceptions. Actually, CXX throws the well-defined exceptions which are based on platform exception. So whenever you throw this kind of exceptions, and if you throw these exceptions, compiler knows that it's supposed to catch it and then return it as a H result, because they always know what the corresponding H result value is. So if you would think how the WRL is, for WRL, you have to put all this try-catch code in your code if you would have the exception throwing code. In this case, compiler does all this work for you.
So this morning you said that we could use WRL as a method of porting simple COM classes into our modern apps or metro-style apps. Can WRL be used to implement COM classes, or just like IUnknown derived classes, or just IInspectable?
It does allow you to implement IUnknown derived classes. But the primary reason for doing that was, again, when you're trying to port, maybe you have to implement an interface that is IUnknown based, not IInspectable based. And so we let you do that.
Okay, thank you.
Where can we define the threading model for the WRL?
So the threading model is WRL itself, right? Internally, we always use interlock increment decrement for reference counting. That's the only thing that we do. And so that's safe. From a point of view of the specifying threading model in the WinMD, you would specify it in the idle file. And then you have to make sure that everything else is correct in WRL. When in your own code, in WRL, we automatically make sure that your object is agile. That means we do the right things. But if you don't want it agile, there's a way to turn it off and things like that. So idle is where you specify what you want. And then if it's different from the default of WRL, you have to go specify in WRL saying, I don't want it to be agile and things like that. And then make sure that your code is, whatever model you choose, it's friendly to that model.